Hello friends, very good morning. Today we will talk about measures of variability, that is a part of the descriptive and inferential statistics. Earlier we talked about in one lecture measures of central tendency, and that was mean, median and mode. Today we will talk about measures of variability. They are also, you may call it, measures of dispersion. Whether dispersion or variability, it is the one and the same thing. Now, what is this variability means? What does this word dispersion means? Variability of scores mean scatter or spread of the separate scores around their central tendency. Variability is also named as dispersion. Now, for example, I have a set of data consisting of 10 persons. Their scores are 40, 41, 39, 43, 42, 41, 38, 39, 40. Now, here the spread is less. If the score is 40, 90, 80, 20, 10, 75. Now, here the spread is more. So, this index tells us that how much scatter or the spread is in the scores. Because higher the spread, more it will be affected on your results. So, there are 4 measures of variability. Number 1, the range. Number 2, the standard deviation. Number 3, the average deviation. Number 4, the quartile deviation. So, let us talk one by one. Range is a simple and is rarely used, but since it is a part of your course, you must know it. If not of the course, even you must know what is range. So, the first measure of variability or the dispersion is range. Range is simply the interval between the highest and the lowest scores. For example, in a distribution lowest score is 15 and the highest is 51. The person who is getting the maximum marks is 51, the lowest is the 15. So, what will be the range? Range will be 51 minus highest minus lowest. 51 minus 15 is equal to 36. That means, the scores are spread between 1 to 15 and the range is 36. Now, take another example. Suppose the highest score is 45 and the lowest score is 19. The range will be 45 minus 19 is equal to 26. Clear? So, how much the scores are spread, scattered, that range will just indicate us that what is the level of spread. The range is the most general measure of spread or scatter. Now, suppose you have taken a test of 15 students. Everybody has got 50 marks. Everybody has got 50 marks. So, highest is 50, lowest is 0. Highest is 50, lowest is 0. So, 50 minus 0 is equal to 50. That means, the scores are, there is a no spread at all. The value of the highest is your range. So, similarly, it is a very crudest, I have told you, very crudest. Nobody uses it, but as a theoretical we must know. Now, we come to the very important, where in every statistics basically you have to use it. Whether you calculate T or anything, the standard deviation will be calculated. The standard deviation, which is denoted by the symbol ST. The standard deviation is the most stable index of variability and is commonly used in experimental work and in research studies. The conventional use for SD is Greek letter sigma. I have put here sigma. Even we can write with a simple word SD, does not matter. If you write this sigma, this is also standard deviation. So, this is used almost in every practicals and in the research. Now, as in the central tendency, I explained that data are two types, group data and ungrouped data. First, I will try to explain that how standard deviation will be calculated in the ungrouped data. Just for the clarity ready reference, I am saying ungrouped data means where the scores are written in a sequence 45, 30, 80, 17, 18, 15, 20, 30. This is ungrouped data. Now, ungroup data here is, we have given a test to 5 students, the number is 5. The scores x is always, the x means the scores obtained by the person, 6, 8, 10, 12 and the 14. Now, this 6, 8, 10, 12 and 14, these are the raw scores. This is ungroup, no grouping. Now, how we will calculate the standard deviation of this data? Now, the formula of standard deviation is sigma x small x, sigma x square upon n under root. Now, in this formula, n is very clear, n means number of students, number of cases, number of students. How many? 1, 2, 3, 4, 5, 5. What is x? X is nothing. X is x minus m is equal to small x. You subtract mean from the x, the score, that will give you small x. That means deviation, m means mean, deviation of the score from the mean is small x. Now, simple, we are to calculate the small x. Now, before we calculate the small x, we must calculate first of all the mean of this group. Now, what is mean? Sigma x upon n, you know it very well, add it up, it is 50, n is 5, so divide 50 by 5, so mean is 10. Now, see, x minus m, x is 6, m is 10, 6 minus 10 is equal to minus 4, 8 minus 10 is equal to minus 2, 10 minus 10 is equal to 0, 12 minus 10 is equal to 2, 14 minus 10 is equal to minus 4. It is the x. In formula, what you want? X square. Now, just do the x square. So, minus 4 into minus 4 plus 16, minus 2 multiplied by minus 2, 4, 0 into 0 is equal to 0, 2 into 2, 4, minus 4 into minus 4 is equal to 16. So, this is the value of the x square. Sigma means total, add it up. Now, 16, 4, 20, 24 and 16, 40. So, sigma x square is 40. Now, put the formula 40, what is that? 40 by n, 40 by n will be your value. Now, 40 by sigma x square 40, your n is 5, 40 by n under root, divide 8 under root n, the value is coming 2.83. That means the dispersion is up of the 2.83. Now, try to understand what I am speaking. It will be applicable on all the deviation. Higher the value of the dispersion, more will be scatteredness. Less the value of dispersion, lowest will be the scatteredness. For example, let us suppose all the scores are 6, 6, 6, 6, 6. Is there any deviation, dispersion? No. 100% similarity, mean is 6, x minus m, 6 minus 6, 0, 8, 6 minus 6, 0, all 6. Now, x square 0, sigma x square 0 upon 5. So, anything divided or multiplied by 0 is equal to 5, under root 0, answer will be 0. It means there is no dispersion, the scores are 6, 6, 6, 6 and 6. So, this was the standard deviation of the ungrouped data. Now, how to calculate the standard deviation by the data in the group form? Now, there are two methods, long method, short method. I am explaining the short method. Now, group data, it is clear, 140 to 144 one group, frequency 1. That means one case is lying between 140 to 144, 3 cases are lying between 145 to 149 and 2 cases are lying between 150 to 154, like that, so on. Now, what is the formula? SD is equal to I under root sigma fx the fx dash square upon n minus sigma fx dash upon n whole square. It means that we must know the value of small x. If the small x comes, we can do very well fx, then make it the square also. Now, what is x? I have just told you x minus m is the small x. Now, since it is a short method, I have very clearly written by short method. There is no need to calculate now mean. Now, how we will do with the short method? Listen, try to understand clearly. You just locate the class interval which is almost in between and where the frequency is the highest. Now, if I locate, this is the class interval which is almost in between and the frequency is 10. Now, here write x dash. I will explain, you just listen first, x dash. Now, above plus 1, plus 2, plus 3, minus 4, plus 4, plus 5. Now, just below minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Now, we will say what is plus minus? You see, this 170, 174 is deviating from itself 0. So, x dash is deviation from the assumed mean 0. Once this class interval, the 170, 179 is away from the 170 1 unit, this unit is higher in value. So, plus 1. 180, 184 is 2 unit above 170, higher in value, plus 2, plus 3, plus 4. Now, come here, 165, 169 below 1 unit, less in value, so minus 1. Less in value 2 units below, minus 2. So, likewise, we will first calculate the deviation from the assumed mean, that plus 2, 1, 2, 3, 4, 5, minus 1, 2, 3, 4, 5, 6. Now, what you want? Fx dash, Fx dash, multiply x dash with the frequency. F is 1, x dash is 5. So, 1 into plus 5 is equal to 5, 2 into plus 4 plus 8, 4 into plus 3 12, 5 into 2 10, 8 into 1 8, 10 into 0 is equal to 0. Now, 6 minus 1 minus 6, 4 into minus 2 minus 8, 4 into minus 3 minus 12, like minus 8 minus 15. Now, what you want? Fx, you want Fx dash. So, these are plus, these are the minus. So, plus value are 43 and the minus are 53. Subtract, it is coming 12. So, the value of Fx dash is now minus 12. Now, you want Fx dash square. Now, Fx dash square is Fx dash into x dash. Don't do 5 multiplied by 5, it will be Fx dash whole square. It is not whole square, it is Fx dash square. So, Fx dash 5, x dash 5, 25, Fx dash 8, x dash 4, 32, 12 into 3, 36, 10 into 2, 20, 8 into 1, 8, minus 6 into minus 1 plus 6, minus 8 into minus 2, 16. So, like that you will get the value of the Fx dash square. Now, put the formula I. What is I? I have told you in the central tendency size of the class interval. This 140 to 144 is composed of how many digits? Is other 5, 140, 141, 142, 143 and 144. The size of the class interval is 5, I, it is 5, sigma Fx dash square 322, 320 upon n, n is 50, 50 minus sigma Fx dash upon n. What is sigma Fx dash? Minus 12, minus 12 upon 50 whole square. Now, solve it, divide it, it is coming 6.40. Now, divide it, it is coming minus 0.24. Now, 6.40 minus, multiply minus 0.24 by minus 0.24, minus will be plus. So, it is 0.576. We have subtracted it, then find out the under root. Under root is 2.52. So, multiply 5 by 2.52, the answer will be 12.60. So, value of standard deviation will be 12.60. Now, the third is the average deviation. Average deviation is a measure of deviation. It is also written as mean deviation MD, average deviation AD, one and the same thing, is the mean of the deviation of all the separate scores in a series taken from the mean. In averaging deviation, to find the AD, no account is taken of signs and all the deviation are added irrespective of the sign. How? I will tell you. Now, again average deviation of the ungrouped data. The data is 6, 8, 10, 12 and the 14. The formula of AD is, it is written here, AD is equal to sigma bar parallel bar upon n, sigma bar x upon n. Where this bar is put, it means addition irrespective of the sign. Whether it is plus or minus, it will be added up, and x is same as we have done in the standard deviation. So, first we find the mean is now 10, x minus m small x as in the standard deviation, 6 minus 10 minus 4, 8 minus 10 minus 2, 0, 2 minus 2. Now, sigma bar x, addition irrespective of the sign, 4 to 6 to 8 and 4, it is 12. Now, this value is 12 and n is 5, AD is equal to 12 by 5 is equal to 2.40. So, this is the average deviation when the data is in the ungrouped form. Now, how to calculate the data in the group form? Now, this is the group data as we have seen in the standard deviation. See the formula, AD is equal to sigma upon fx upon n. Again bar, addition irrespective of the sign. Now, f is there, x. What is x? Deviation from x is the deviation from the mean. So, first of all, we will find the mean of the problem. What we will do? We will find the mean of the problem. Then we will calculate, we will find the mid value, because who will represent this data in a single unit? The mid value. 140 to 144, 140, 141, 142, 143, 144. The mid value is 142. So, first calculate the mid value of all the scores, then calculate the mean. Then you do x minus m is equal to small x. Subtract this x from the mean, it will be 26.2, 21.20, 16.20, 11.20. Like that, you will come to the value of the small x. Now, what do you want? Fx. Multiply this x by frequency f. F is 1, 26.20. So, 1 multiplied by 26.20 is 26.20. 2 multiplied by 21.20, 42.40. Likewise, we will multiply all the frequencies with their respective small x value. Now, what is the formula? AD is equal to sigma bar fx. Bar I have told you, addition irrespective of the sign, whether plus or minus. So, just add it up, don't bother about minus and the plus. When you will add it up, this value will come 502. Now, AD is equal to sigma bar fx, that is 502 upon n is the number of cases, that is 50. I put 50 here. So, 502 divided by 50 is equal to 10.04. So, this way the value of the average deviation will be calculated. Now, the fourth is called as the quartile deviation. The quartile deviation is half the scale distance between the 75th and 25th percentile in a frequency distribution. The 25th percentile, that is Q1, quartile first, is the first quartile on the score scale, the point below which 25% of the score are coming. The 75th percentile is Q3, Q3 means 75th percentile, is the third quartile on the score scale, the point value which lie 75% of the cases. And when we have these two points, the quartile deviation is determined. So, for determining the quartile, first we will have to find out the first quartile, that is Q1, and then we have to find the third quartile, that is Q3. Now, this is the formula of the quartile deviation. You see, Q is equal to Q3 minus Q1 upon 2. So, you have to find out the third quartile and then the first quartile. Now, what is the formula of the first quartile. L plus n by 4 minus f upon fq. What is L? L, lower limit of the class interval in which n by 4 lies. Where n by 4 will come, we will take the lower limit of that class interval. Where it lies, we will just see. Capital F, sum of the frequencies of those class intervals which are less in value than the class interval in which n by 4 is coming. The class interval in which n by 4 is coming, add the values of those class interval which are less in value. Fq, frequency of the class interval in which n by 4 is lying, its actual frequency, and I is the size of the class interval. Now, similarly, when you will come to Q3, what will be the value of L? Lower limit of the class interval in which 3n upon 4 is coming. Here it was written for quartile 1 n by 4, since it is third percentile, so it will become 3n by 4. Now, let us calculate both and then try to see that what is the value of the quartile deviation. As I told you, first of all, we will have to find out the value of first quartile and then the third quartile, and then we will come to the answer, that is Q. Now, first of all, you can find out, you work out the cumulative frequencies. Cumulative means addition, and that addition will start from the group data which is lowest in value. This is 140 to 144. Now, it is only 1. Next, 145 to 149, frequency 3. So, 1 plus 3 is equal to 4. Next 2, 4 plus 2 is equal to 6. Next 4, 6 plus 4 is equal to 10. Then 4, 10 plus 4 is equal to 14. Then 6, 14 plus 6, 20. Then 10, 20 plus 10, 30. Then 8, 30 plus 8, 38. Then 5, 38 plus 5, 43. Then 4, 43 plus 4, 47. Then 2, 47 plus 2, 49. And last one, 49 plus 1, 50. So, you will find out the cumulative frequencies of the class intervals. Now, suppose this problem is reversed, starting from top 140 to 149 and then coming lower on the higher side 145, 49. Then you will find f from the upper side, the higher side. It must be started from that class interval which is lowest in its value. Fine. Now, you have calculated the value of f. Now, first quartile, L plus n by 4 minus f upon fq into I, n by 4 first quartile. What is the value of total n? 50. So, first quartile, that is 25th, will be 50 divided by this 4 is equal to 12.5. It means the first quartile will lie somewhere where the scores are 12.5. Now, search the class interval where the scores are 12.5 is coming. So, it is 1, 4, 6, 10, now it is 14. Now, it means the class interval of 160 to 164 is that class interval in which Q1 is coming or Q1 is lying. Because my value is 12.5, it is 10, 10 onwards up to 14 are coming in which class interval? 160 to 164. Now, L, the lowest value in which n by 4 is coming. So, n by 4 you know is coming in 160 to 164, 160 is lowest value, L will be lower limit 159.5. I have already told you, if you have to find the lowest value, subtract 0.5, if you want the upper limit, add 0.5. So, in 160 I have subtracted 0.5, this value is coming as 159.5. Now, so L is there plus n by 4 that you have already calculated 12.5 minus f. What was capital F? The sum of frequencies of those class intervals which are less in value than the class interval in which n by 4 is coming. So, n by 4 is coming in 160 to 164. Now, the values which are less in value are 155, 150, 141, 49. So, add their frequencies. We have already done, it is 10. So, the value of now this is 10 and FQ, the frequency of the class interval in which n by 4 is coming. So, n by 4 is coming in 160, 164, its actual frequency is 4. So, we have put it 4. Now, solve it. When you solve the second part, the value is coming 3.12. So, this is equal to 159.5 plus 3.12 and that is equal to 162.62. So, we have calculated the first quartile. Now, you will have to calculate the third quartile. The third quartile will be calculated similarly as we have calculated the first quartile. Formula I have told you earlier, L plus 3n by 4 minus f into upon fq into I. You know 3, why 3? Because it is a third quartile, third percentile. So, 3 n by 4, n is 50, 3 by into 50 is equal upon 4 is equal to 37.5. Now, search where the 37.5 is coming. Now, up to here 30, from 30 onward up to 38, it is coming in 175 to 179. So, what is the value of lower value of this class interval? 175, 174.5 plus 3n by 4, 37.5 minus the sum of frequencies of those class interval which are less in value than the class interval in which 3n by 4 is coming. Now, you see which is what is that class interval. So, it is coming here. So, the less in values are below this. Now, this we have already added up 30. So, this is the capital F is 30, FQ, its actual frequency that is 8 and rest you know I is the 5. Now, you just solve it and when you will solve it, the value answer will come as the 179.18. Now, 179.18, what is Q? Q3 minus Q1, Q3 minus Q1, 179.18 minus 162.62 upon 2, just solve it, you will get answer 8.28. So, 8.28 is the quartile deviation of this score. So, in this way we calculate the level of dispersion of the scores. The SD is very important, it is used number of times in the scientific research also. This is about your variability. I am sure you must have understood it. Thank you very much.